The Cimb Niaga Graha building occupies an area of approximately 10,800 square meters and was built in 1993. This office building has a typical 28 floors, 3 basement floors, and 2 podium floors, banking hall and function hall with a total gross area of 58,000 square meters. Located at Jalan Jenderal Sudirman, Kavling 58, Jakarta 12910. Energy-saving efforts. In order to achieve energy savings, Graha Niaga as the operator has compiled a number of extensive integrated programs since 2010 to continue to be able to obtain energy savings from year to year. Until 2021, Graha Niaga has achieved savings of up to 31.7% from the 2010 baseline. The average energy savings from 2010 to 2021 is 1,717,845 kilowatt-hours, or equal to USD 173,502 per year. Spatial organization for various functions. This office building has a typical 28 floors, 3 basement floors, and 2 podium floors with a total gross area of 58,000 square meters. Besides office area, this building also equipped with facilities such as banking hall, function hall, restaurant, fitness center, etc. Environmental improvement of surroundings. The site plan is designed to comply open green space of 30%. Some mini elephant grass is planted on the lower garden area, accompanied with some palm sardeng, or in its Latin name known as Livistona rotundifolia, which is aged at above 15 years. Surrounding the grass is also some nuts-type plants, Xena, with yellow leaf. And in this area, there is also a philodendron with big leaves that has also aged over 15 years, and below it there are some Bakinger Manka and Hujan Mars. The upper garden has the same types of plants as the lower area, however the upper area does not have philo-type plants and daffodils, but there are some vines being planted on the pergola area named Alamanda. In addition to that, we have a vertical garden that is indeed a target of open green space, 30% plastered above. The expanse of granite on the fence of the building continues to meet every edge, first settled with green and yellow cascade series of ivory and yellow flowered mini solar plant. Envelope design, material, shading, fenestration, etc. Graha Cimb Niaga, designed by world-renowned architects Cohn Pedersen Fox Associates, KPF, New York, is well known for its distinct architecture, reminiscent of the 20s and 30s. The innovative design and aesthetic merits has made Graha Cimb Niaga one of the most notable landmarks on Jalan Sudirman, with a postmodernism architectural style from 1920 to 1930, which has a classic facade that incidentally is not dominated by glass like today's modern buildings. This building has a sheath with a window-to-wall (WWR) ratio of 41%, which is relatively small and can increase the building's ability to withstand the heat of the sun. Material. Graha Cimb Niaga uses classical design with walls fitted with a stylish mix of imported granite, marble, stainless steel and aluminum, all working together to render the building as majestic and luxurious. In addition, the main side, the northwest, is coated with glass and coated with grey aluminum, and the southeast side, which faces the residential areas of Kebayoran Baru and Senayan, is covered with granite with relatively small windows. Sun shading. The mass of the Cimb Niaga Graha building is in the general shape of a rectangular beam geometry, where the front view faces northwest, namely Jalan Jenderal Sudirman. The other 3 look to the northeast, southeast and southwest. This means that there is no side of the building that actually faces perpendicular to the east and west, which is vulnerable to the heat of the sun. Overall heat transfer through building envelope. The calculation result of the overall building envelope are archived. Overall thermal transfer value, OTTV, which is 29.56 Wm2. Thermal transfer value, RTTV, which is 10.67 Wm2. To reduce solar radiation, windows are also equipped with aluminum sun shading. In order to create a dynamic impression, sun shading is made with a combination of dimensions. On the facade facing the northeast, with a relatively dominant window glass material, sun shading is designed with long dimensions. Meanwhile, on the facade that faces the southwest and southeast with more dominant massive materials and relatively more marginal window glass, sun shading is designed with short dimensions according to the width of the window opening. Fenestration. In order to control the level of incoming solar radiation, Graha Cimb Niaga is also designed to use glass with special specifications. Based on the results of the lighting and shadow studies, which were determined from the type of facade material and window openings, as well as to anticipate east and west sunlight, the glass specifications were determined. Natural ventilation. Natural ventilation is optimized in the parking building area, which consists of 5 floors, with the concept of cross ventilation, which is through from one side to the other so that air can circulate freely. Vertical garden in the form of vines is expected to reduce CO and pollutant levels, thus making the incoming air relatively fresher and more comfortable for building user. Air conditioning system. As a major contributor in building energy consumption, air conditioning systems are the main target in energy efficiency efforts. Cimb Niaga's Graha building has carried out chiller retrofitting in 2013 and most recently in 2021 to achieve energy savings of 31% compared to the energy consumption baseline in 2010. Currently the building is conditioned to use 5 units of water-cooled centrifugal chiller consisting of 3 chiller units with capacity of 350 TR/. Based on the measurement of building cooling load, Graha Cimb Niaga has a peak cooling load of 1000 TR or 78.7 Wm2. Meanwhile, based on the cooling load profile record, Graha Cimb Niaga has daily cooling loads with the highest or most frequent frequency being 900 TR and 700 TR. Based on this profile, the chillers that operate daily are chillers with a capacity of 1000 TR and 720 TR, while other chillers only work as backups or when low load. As an energy efficiency measure, the air conditioning system is equipped with variable air volume, VAV, so that the room is conditioned according to the volume of airflow required. If the air temperature set point has been reached, the air handling unit, AHU, which has been equipped with a VSD, will adjust the airflow speed so as to save energy. The chiller pump and condenser pump have also been equipped with a variable speed drive, VSD, so that the system can work according to the needs of the chilled water flow volume. When the room set point is reached, the pump will reduce the motor speed to reduce the chilled water flow so as to reduce energy consumption. Based on data recorded on the Building Automation System, BAS, currently the chiller plant system has an efficiency of 0.68 kilowatts per TR, based on the classification of the coefficient of performance, COP, of the chiller plant according to ASHRAE. This value is classified in the excellent, high-efficiency optimized chiller plant category. Lighting system. Currently the Cimb Niaga Graha building is equipped with a TL lamp lighting system with a light power density, LPD, value of 5.6 Wm2 or 30% more efficient than standard 8 Watt M2. These savings efforts are carried out without compromising the quality of the minimum lighting strength of 350 lux for office buildings. As the second target in energy saving efforts, the lighting system continues to be pursued to obtain energy savings. In 2014, motion sensors were used for meeting rooms and emergency stairs so that in these areas the lights only operate when occupied. In 2015, the conventional ballast was replaced with a high-frequency electronic ballast. To achieve significant energy savings, it is planned to retrofit all lamps to LEDs. Indoor air quality. The building is equipped by indoor air quality monitoring that can be monitored online by mobile phone. The parameters are including virus index, temperature, humidity, air pressure, CO2, TVOC, PM2.5, NO2, ozone, etc.